Okay, so we're looking at z-scores that don't fall neatly on the standard deviations, and that's typically what you're going to run into. And you're going to have to take a look at, as we did with the previous distribution, what is the area above it, below it, or between two different scores. And I think we were asking about the area between two different scores, which I believe were 0.73 for one person and a z-score of negative 0.67 for the other. So you're going to have to refer to the z-table. Now, it won't be this exact page number. However, it will look just like this. You'll notice that each of these columns, we have one here, here, and here, are also divided into three columns. Column A, column B, and column C. Column A gives us the z-scores. So the z-scores are all in the column A. So when you're looking up the z in particular that you want, column A will be the z. Column B, this column, if you look at the shaded area, what column B is telling you is what's the area under the curve from your z-score to the mean. Column C, which is here, column C is telling you what is the area under the curve from your z-score to the tail. And if you look towards the bottom of the page, you'll see that the same thing reflects on the negative or the low end of the distribution. You won't find the negative or positive represented in the Z column in column A. Reason being is because the graph is symmetrical. So if it's a positive or a negative, it's still going to be in column A. Okay, so this is a large view, which it wouldn't let me do before, and hopefully it will. It's a little easier to see on this one. Columns A, columns B, and column C. And like we said a few seconds ago, A gives you your z-scores, and you can see them a little more enlarged here. B, column B, gives you the area between the z-score and the mean, and column C gives you the z-score to the tail. Now, we were talking about those two individuals whose z-scores were 0.73. So on finding this, we would go to column A and we'd look for 0.73, which would take us right down to here. 0.773. So there it is right there. Now, as we look across, I'm going to try to draw this in here. I'll circle this over. For 0.73, we know that 0.2673 from this z-score to the mean, or 26.73% of a population would be between this z-score and the mean. And in the C column, 0.2327 lets us know that 23.27% of the population is from this z-score to the tail. Now we're trying to figure out what's between these two particular z-scores. The other one is a negative. Now, the column, what happens on one side of the graph happens on the other. So it makes no difference. But if you go all the way down, and I'm not going to do it here, if you go all the way down to the bottom of this, you'll see that it has the negative. But it's negative or positive. The other z-score was negative 0.67, which we'll find right here, 0.67. And the same information is given here. Column B will tell us the area under the curve, or the percentage or the proportion between this z-score and the mean. And column C will give us the percentage or the proportion from this z-score to the tail. And if we want to know what the area was between these two z-scores, because this one here is negative and this one's positive, they're on either side of the mean. So we could go to column B, which would be for negative 0.67, we would have a proportion of 0.2486. And then we could go to the column B, since this is above the mean, where we have 0.2673. And then we would add those together to tell us the total area under the curve between those 2 points. And now let's take a quick look at a normal distribution and some of the combinations that you'll be asked or information you're going to have to assess by using both this type of a chart and the normal distribution. Okay, again, now in using the chart, depending upon the question you have, is going to depend upon how you approach it. But just as a basic sort of rule, if you're looking at column B, the B column, and we'll write B here, B column gives you the value or the area under the curve from wherever your x point is to the mean. So B over here, if you had a negative, remember it's all the same. B gives you from whatever that negative z-score is to its mean. On the other hand, C, the C column, gives you from whatever that z point is to the tail. Same on the low end. C gives you whatever that value is, and then to the tail. Now, it's depending upon how the questions are worded, you're going to have to approach the chart and the normal distribution differently. So let's say, for example, if you're looking for an x value, you have your z, and it wants to know the percentile ranking or what percentage of the population scored equal to that or below. So if it's here, and it wants to know the, again, equal to or below or percentile rank, at this point you would take B, right? That would be the B column to the mean. If this is above the mean, if the z-score is a positive z, and then all the way down, sorry about the curve in that, and then you would have this 50%, and you would have to add those together. So the B column, and then the bottom 50%. If the z-score you're looking at, if that value is below the mean, and you want to know the percentile rank, then it's going to be the C column. If you have, let's say, I'm going to change the color again. Let's say you have a z-score that's here, and you want to know everything above that score. Well, then that's going to be the C column. If your z-score is below the mean, so it's a negative z-score, and you want to know everything from this point and above, you're going to take it to here, which would be B, and then the rest of the way, which is the other 50%. And again, it's going to depend upon the scores that you're looking at and what the questions are asking you. So if we were to take, let's say, for example, we wanted to know, we have one value here and another value here, and we want to know the distance between these two values. Well, then you're going to have to take a look at this one to the mean, and then this one to the mean, and those would both be B columns, and then subtract the difference. Same as if they were, let's say they were both negative z-scores, and you wanted to know the distance between these two. You want to know how far apart are these two. Well, again, these are both going to be B, and subtracting the difference. So if they're on the same side of the mean, and you want to know the space in between, or the proportion in between, go B column for both of them and subtract, and that'll give you the difference. Now, if they're on opposite sides, then it's a little bit different. If they're on opposite sides, like let's say one of the scores is here, we'll do it in green, and the other score is here. And you want to know the space between these two. So the space from this one to this one. What's the proportion? What's the percentage of the population between those? Well, then it's going to be this one to the mean, which would be B, and this one to the mean, which would also be B, and then you're going to add those together. That's the basic way to use that chart when answering certain questions. So if we say we have a z-score of 1 and a z-score of -1, and what's the proportion between those? Well, that's going to be the green one here that we just did. Let's say we had a z-score of -2.5, and we want to know what percentage of people did better than that person, equal to or better than that person. Well, then that's going to be this one right here. So it's going to depend upon what the question's asking, and you can draw this out. I would recommend it, actually. Draw out the graph and map out what's the question asking and draw it out. That way you can visualize it if it helps. And of course, obviously, replay the videos as much as you need to.